99% of the time, L'Hopital's rule will be able to handle any indeterminate form a limit throws at you. However, this is in that 1% of cases where L'Hopital's rule fails us. So here's what we're going to do. I'm going to go ahead and plug in infinity. When I do, I get infinity in the numerator. Infinity squared plus 1 is infinity. The square root of that is also infinity. So I have infinity over infinity. That would tell us to take the derivative of the top and the bottom of this expression. I'm going to save you the trouble of taking the derivative of the top and the bottom here and just tell you that when you take that derivative, you get square root of x squared plus 1 on the top, and you get x in the bottom, which looks awfully familiar. In fact, it looks like the reciprocal of that expression. Okay, that's fine. Well, when I plug in infinity this time, what do I get? Well, I still get infinity over infinity. Okay, that's fine. We've seen plenty of times where a limit has had us do a L'Hopital's rule more than once. When I do L'Hopital's rule one more time, though, guess what? I get right back to the limit I started at. So this didn't seem to help at all because I'm just going to go in a circle forever. Instead, we want to resort to algebraic techniques to evaluate this limit. We want to say to ourselves, what's the degree or the power of x in the numerator? That power is 1. Now you might say the power of x in the denominator is 2, but we're applying a square root to it. So effectively, the power of the denominator is also 1. So we have effectively limit as x goes to infinity of x over, technically the square root of x squared is absolute value of x. So we're going to say the absolute value of x. It won't make too much of a difference here because we're going to positive infinity, but if we'd been going to negative infinity, we'd have to switch things up by a sign. And in this case, we have x over absolute value of x. Limit as x goes to positive infinity would just be 1. And that is my answer.